Hello everyone. In this video, we'll be solving problems on field and potential due to dipole. Okay. So this is the first problem. A small dipole of dipole moment P is equal to Pi cap is kept at the origin. Find the electric field and potential at the following points. These are the coordinates of all the points. There are 7 points where we are supposed to calculate the field and potential. Okay. So first, let's draw the situation. This let's say that this is the x-axis, this is the y-axis, and this is the z-axis. Okay, this is for reference, and we draw the dipole here at the origin. Let's say this is the dipole right here. This is a dipole P. Okay, this is our dipole P. Now the first point. Where is the first point? The first point is here. We're supposed to find the potential and field at this point. Now, before we do that, let's just write the formula for both electric field and potential due to a dipole. So the electric field due to a dipole at a point is given by Kp by r cube times root of 1 plus 3 cos square theta, where what is r is the distance of the point from the dipole, p is the dipole moment itself, and theta is the angle between the position vector and the dipole moment. Okay, so here first, in the first case, you can see that theta is 0, as the position vector is like this is the position vector and it is parallel to p. Okay, and r is a because this distance is a. And also, yes, we are supposed to write the potential as well. So what is the formula for potential? It is Kp cos theta by r square. Kp cos theta by r square. All right. So this is the first point. This is point number one. Coordinates are a comma 0 comma 0. Now for this point number one, what is the value of r? The value of r is a and the value of theta is 0. So let's just plug in the values. The first answer would be E is equal to K P by R is A. So it would be A cube times root of 1 plus cos square, 1 plus 3 times cos square 0. Cos of 0 is 1. So 1 plus 3 is 4. Root of 4 is 2. So this is going to be 2 Kp by A cube. All right. And you could also see that this is a point on the axis of the dipole. So you could, if you remember the formula of that, you could write that as well. Okay. And the potential, what would be the potential? It is going to be Kp by A square. Okay. So that was case number one. Now the next point is, point number two is here on the y-axis. Okay, you should understand that this is the x-axis, this is the y, and this is the z. Okay, now this is point number two. Now for point number two, you can see that the angle between the r vector and r vector and p vector is 90. So here r, the value of r is again a, while theta is equal to 90. Okay, theta is the 90. You could also see that this particular point is on the equatorial plane of the dipole. All right. So case 2, question number 2, electric field is going to be equal to Kp by A cube because it's on the equatorial plane. Or you could see that just plug in the value of theta. It is going to be cos 0 is 0. Sorry, cos of 90 is 0. And hence you'll get root of 1, which is 1. So Kp by R cube, which is A. R is A. So Kp by A cube. And V is going to be 0. It's on the equatorial plane. Now the next point is on the z axis, and you could clearly see that there isn't many difference between point 2 and point 3, uh, since they're both on the equatorial plane. Here r is equal to a, and theta is equal to again pi by 2. Okay, so you'll get the same result in case number 3, which is E equals kp by a cube, while v is equal to 0. Now what's next? Question number 4. It's on the point is on the uh, xy plane. This is the point. This is point number 3. So what is the distance between the dipole and this point? You can see that it is root 2a. So here you can see that this is root 2 times a. Okay. So r is going to be equal to root 2 times a. While what about theta? This is theta, right? So what is theta going to be? Theta is going to be pi by 4. You can see that theta is equal to pi by 4. All right. So uh, the fourth one, you plug in the values. It is going to be kp by 2 root 2 a cube times root of 1 plus 3 into cos of pi by 4 is 1 by root 2. The square of that is 1 by 2. So 3, I'll write it like this, 3 by 2. Okay. So what's the final answer? You can see that I'll get a root 5 on the in the numerator, and a root 2, and that root 2 will get multiplied with this root 2. And finally you have E is equal to root 5 kp over 4a cube. That's the electric field. All right. What about potential? Potential is going to be equal to k p cos 45 is 1 over root 2 divided by 2a squared. Okay, so that is going to be k p by 2 root 2 a squared. All right. So that was question number 1, 2, 3, and 4. Now let's look at question number 5. Question number 5, as you can see, is on the YZ plane. Okay, so let's just try and mark that point. So this is that point, and again you can see that the distance between the dipole and that point is root 2a. This is again root 2 times a, but the angle here is 90 degrees because it is on the equatorial plane. Okay. So this is question number, oh, sorry, I just made a mistake here. This is supposed to be fourth, and this is fifth point. The value of r is root 2a, while theta is 90. Okay, let's find out the value of E and V. So in question number 5, E is going to be equal to, you see, k p over 2 root 2 a cube times 1 plus 3 into cos of 90. Cos of 90 is 0. So this is going to be 0, and you'll end up with root of 1, that is 1. So this is the final answer, kp over root 2, 2 root 2 a cube. And since this point is on the equatorial plane, you can say that voltage is going to be equal to 0. All right. Now, the next point is point number 6, which is on the xz plane. If you try and mark that point, you can see that it is here, and there isn't much difference between point 4 and point 6. Okay, so you can see that the distance between the dipole and that point is again root 2a, and the angle is theta equals pi over 4. Okay. So for point number 6, r is again root 2a and theta is equal to pi over 4. So since it is similar to question number 4, I'll just directly write the answer. That is, E is going to be root 5 kp over 4a cube, and V is going to be kp by 2 root 2 a square. All right. So that was the electric field and potential of the first 6 points. Now, I think I should do the seventh point freshly. So I'm going to erase the board. You may pause the video and note it down, note everything down. Okay. So this one right here, the last one is, let's say this is the x-axis, this is the y-axis, and this is the z-axis. And our dipole is right here. And we are supposed to find the field at this point, a comma a comma a. Now, if you can imagine a cube of side a, this would be on the opposite corner of the dipole, right? Let's say that this is x, y, and z. And what would be the angle made by the position vector? What is this position vector? This right here is the position vector. And this distance is first of all going to be equal to root 3a. You could just square each one of them. A squared plus a squared plus a squared root of a squared plus a squared plus a squared, and you'll get 3a, root 3a. All right. And what would be this angle? This angle right here, theta. It's a three-dimensional angle. It's not on either of the planes. It's neither on xy plane, nor on xz, nor on yz. Uh, it's a 3D angle, theta. So how will we, find that? So if you remember in the chapter vectors, I've taught you about direction cosines. So you can use that logic, and you can see that cos theta is simply going to be equal to a by root 3a. So that is 1 over root 3. Okay. So cos theta is equal to 1 over root 3. So by the formula of E and V, what was E? E was kp by r cube root of 1 plus 3 cos square theta. And V was kp by r square into cos theta. Right? So I need cos theta, so I don't have to change this to any other form. And you can see that r the value of r is root 3a. So let's just plug it in. Question number 7. E is equal to kp by 3 root 3a cube root of 1 plus 3 times cos theta is 1 by 3. So this would be 1 over 3. Cos square theta would be 1 over 3. So what's the final answer? You'll get root 2 kp by 3 root 3 a cube. That's the answer. That's your field. You should understand that I've just found the magnitude of the field. I don't care about the direction. If you think hard, you can also find the direction. This is just as a practice for you to find the electric field at whatever point is being asked. Okay. So that is the electric field. And what about potential? V is going to be kp over r square. R square is going to be 3a squared into cos theta. Cos theta is 1 over root 3. So the answer is Kp over 3 root 3 a squared. All right. All right. This is the next problem. A small dipole of dipole moment P is equal to Pi cap is kept at the origin. Find the work done in taking a point charge plus Q from minus 3a comma 4a to 8a comma 6a. So first of all, let's draw the diagram, and you can see that this only involves the xy plane. Let's say this is the x-axis and this is the y-axis, x-axis and y-axis. This is our dipole P. Now you're supposed to take that charge, point charge, from minus 3a comma 4a. Minus 3a comma 4a is in the second quadrant, uh, somewhere here. I think, yeah, here, to 8a comma 6a. 8a comma 6a. It's somewhere here, right? So you're supposed to take this charge from, let's say, point A to point B. Point A is minus 3a comma 4a and point B is 8a comma 6a. So first of all, let's try to find the distance of these 2 points from the dipole. So the distance would be, as you can clearly see here, these two distances are simply going to be 5a and 10a. 5a and 10a. Now, what is the angle made? What is the angle made by these two position vectors with the positive direction of the dipole? Okay, so this particular angle, you can see that this angle is this is 8a comma 6a. So this, or along the x-axis it is 8a and along the y-axis it is 6a. So you can say that this angle is 37. This angle should be 37 degrees, while this angle has to be 53. You can do that. You can see that if you go towards left, you'll have to move 3 units and then up by 4 units. So this is a triangle of 3 and 4, and this angle is 53 degrees. All right. Now, what is the angle made by this particular position vector with the positive x-axis? It is going to be 180 minus 53. All right. This has to be 180 minus 53. Okay. Now, what is the work done? Work done in taking a point charge from point A to point B. So the work done would simply be, now see, there are two possibilities here. They could either ask you for the work done by the electric field, or they might ask you for the work done by the external agent. Generally, they ask you for the work done by the external agent, and this work done is simply going to be change in potential energy of the particle. Okay, so it is going to be simply delta U, or simply UB minus UA. All right, and what is UB? UB is going to be Q times VB, while UA is going to be Q times VA. All right, since this is positive charge, you don't have to change the signs. So I'll write it like this: Q times VB minus VA. Okay. Now let's just individually calculate VA and VB. What is the potential? What's the formula of potential due to a dipole? It is Kp cos theta over r square. Cos theta over r square. Okay. So VA is going to be Kp cos of 180 minus 53, 180 minus 53 over r square, which is 5a square of 5a. Okay. Now, what is cos of 180 minus 53? It is going to be minus cos of, minus cos of 53. All right. So I can write it like this: Kp, this is going to be negative Kp cos of 53 is going to be 3 over 5 divided by 25 a squared. So we'll get minus 3 Kp by 125 a squared. All right. Similarly, what about Vb? Vb is going to be Kp. Here it's going to be cos of 37 by square of 10a. All right. Now, what is cos of 37? It is 4 over 5 Kp times 4 by 5 upon 100a squared. All right. So this is again, this is going to be Kp by 125 a squared. Okay. I hope I've done it right. Yes. Now just plug in the values. It is going to be Q times Kp. You can see that this is towards the positive side, so the potential at B is going to be positive, and it will be negative over here, right? Now Kp by 125 a squared minus 3 Kp by 125 a squared. So this would turn out to be 4 Kpq by 125 a squared. So that's the answer. All right.